When a main battle tank hailed as the king of land warfare emerges from a smoke-filled border conflict bearing battle scars and missing its gun barrel, should we first question its quality, or heed the complex and brutal whispers from the battlefield? Recently, a photograph originating from the Thai-Cambodian border has stirred considerable online debate. A Chinese-made VT4 main battle tank of the Royal Thai Army stands motionless, its frontal reactive armor charred and curled, bearing clear marks of impact. Most strikingly, the 125mm smoothbore gun barrel, which should be proudly pointing forward, is entirely missing. Certain voices, particularly some Taiwanese media outlets, swiftly latched onto 2 points: the missing barrel and the alleged firing of over 200 rounds, eagerly jumping to conclusions about barrel explosions and substandard quality. Yet the battlefield is never a simple multiple-choice test. Every mark of damage is a complex equation to be solved. Jumping to conclusions based solely on appearances not only risks straying far from the truth, but also shows a fundamental lack of respect for the crew who fought valiantly and for the intricate precision of modern weaponry. Let us revisit the origins of this incident. The disclosure of this photograph was accompanied by a proud account from a crew member of the 21st Cavalry Battalion, 6th Infantry Division, 2nd Army Region of the Royal Thai Army. In a social media post, he praised this VT4 as his unit's most formidable asset. According to his account, since the border conflict erupted, this tank has been at the forefront of combat operations, firing over 200 rounds and effectively deterring the enemy. This figure alone carries significant meaning. Those familiar with tank warfare know that a main battle tank typically carries around 40 rounds as standard ammunition. Firing over 200 rounds signifies that this VT4 underwent multiple high-intensity ammunition resupply cycles, sustained deployments, and near-constant firepower projection. This undoubtedly showcases the crew's heroic tenacity and exceptional sustained combat capability. Simultaneously, however, it serves as an extreme stress test, posing ultimate challenges to the tank's mechanical reliability, cooling systems, and logistical maintenance support. In real battlefield conditions, particularly during high-intensity, fast-paced confrontations like border conflicts, equipment often operates under overloaded and suboptimal conditions. Facing the scars on the turret and the missing barrel, the barrel burst theory seems the most direct and impactful explanation. Yet, upon careful examination of the typical characteristics of a barrel burst, numerous doubts emerge. A barrel burst typically occurs when a projectile explodes inside the chamber during firing, or when high-pressure gases unexpectedly rupture the barrel wall, releasing immense energy violently within the barrel and turret in an instant. When such an accident occurs, the consequences are catastrophic. Massive shockwaves and high-velocity fragments ricochet repeatedly within the enclosed turret, inflicting devastating casualties on the crew. The turret interior bears severe scorch marks, tearing, and structural deformation. The barrel typically twists, fractures, or ruptures from the middle or near the breech, with the fracture surface often jagged and irregular. In contrast, examining the VT4, existing photographs show that while the frontal turret armor is damaged, its structure remains largely intact. The detonation and spalling of reactive armor serve as proof of its effectiveness. It redirected and dissipated the attack's energy outward. Most crucially, there are currently no reports of casualties among the vehicle's 3 crew members. Had this been an implosive barrel burst powerful enough to blow the entire heavy gun barrel off, the crew would have had almost no chance of surviving unscathed. Therefore, the evidence at the scene, and the fact that the crew survived diverge significantly from the typical characteristics of a barrel burst. Instead, it strongly suggests that the tank's protection system successfully withstood one or more external attacks, blocking the lethal threat outside the crew compartment. So, on the fiercely contested battlefield, what plausible explanations might there be for the loss of a main gun besides a barrel burst? The possibilities are actually numerous, each one illustrating the brutality and complexity of combat. First, extremely high firing rates themselves represent a brutal drain on barrel life. The service life of modern tank barrels is typically measured in full charge rounds fired. Under ideal testing conditions, an advanced 125mm smoothbore gun might achieve a lifespan of around 500 rounds. However, actual combat is far from an ideal laboratory. Continuous high-velocity firing causes the barrel to accumulate extreme heat, generating severe thermal stress and fatigue. Firing different types of ammunition produces varying chamber pressure curves. Dust and humidity in border regions can erode rifling grooves, and during intense combat, strict adherence to post-firing barrel cleaning, cooling, and routine maintenance may be impossible. All these factors combined drastically accelerate material fatigue and aging. Ultimately, sustained firing can cause barrel cracks, expansion, or even structural failure. Such failure may not manifest as an instantaneous explosion, but could instead present as severe performance degradation, prompting crew or maintenance personnel to proactively remove and replace the barrel. Alternatively, it might occur during a subsequent firing due to insufficient strength, resulting in fracture. Secondly, external attack represents another highly probable cause. Tanks are the most conspicuous targets on the battlefield, drawing concentrated fire from various anti-tank weapons. Even if an anti-tank missile, rocket, or large-caliber shell fails to directly penetrate the VT4's robust main armor, a direct hit near the barrel root, muzzle brake, or shield area could generate immense impact and explosive stresses. This force is entirely capable of causing the relatively slender external barrel component to bend, tear, or be severed from its mounting. Certain anti-tank munitions, such as top attack rounds, or those designed to generate massive shock waves, are specifically engineered not to penetrate armor, but to destroy external equipment through explosions and injure crew members via blast effects. As a prominent and critical external component, the gun barrel is particularly vulnerable to such attacks. Additionally, the possibility of accidental mechanical damage to the barrel, such as collisions with obstacles during combat or movement, cannot be entirely ruled out. Shifting focus from isolated damage incidents to the VT4 itself may offer clearer perspective. As China's independently developed next-generation export main battle tank, the VT4 incorporates the nation's latest advancements in armored vehicle technology. It boasts a powerful 1,200 horsepower power pack, granting it outstanding mobility. Its hull and turret utilize matrix composite armor, with the option to add modular explosive reactive armor based on threat levels, placing its protection among the top in its class internationally. The 125mm smoothbore gun, paired with an advanced fire control system and diverse ammunition types, delivers formidable striking power. More importantly, the design philosophy of modern main battle tanks has evolved from pursuing impenetrable mobile fortresses to emphasizing comprehensive battlefield survivability. This includes modular armor that is easily replaceable after hits, compartmentalized design to prevent secondary effects, advanced fire suppression and blast mitigation systems, and the critical principle of prioritizing crew survival. In this incident, the VT4's armor modules absorbed the attack's energy and sustained expected damage, while the crew compartment remained intact, ensuring the crew's safety. For the Thai Army, the operator, this incident undoubtedly provides invaluable real-world experience. It may suggest that, when deploying advanced main battle tanks like the VT4 for prolonged border standoffs and high-intensity fire suppression, more scientific planning of operational cadences and logistical maintenance cycles is required. This may necessitate stricter firing intervals to ensure adequate cooling of the gun barrel and critical components, deploying more specialized maintenance teams at the front lines for rapid diagnostics and part replacements, or tactically rotating tanks between frontline assault, fire support, and mobile defense roles to prevent excessive wear on individual vehicles. While military equipment is built of steel, sustained combat effectiveness demands meticulous operation and maintenance.